Today we'll be looking at dimensions, which form the basis of what you need to know in physics. Physics is the study of natural phenomenon at its most fundamental level. Now, in physics, quantities in physics are located with units. There's what is called the fundamental units, and there is what is called the derived units. The fundamental units are units allocated to what fundamental quantities, while derived units are units obtained by combination of two or more fundamental units. The basic fundamental quantities in physics are mass, length, and time. The mass, the length, and the time. Although there are other fundamental quantities like temperature. The unit of temperature is the Kelvin. We have the amount of substance. The unit is what? The mole. And then we have current. The unit of that is what? The ampere. But the three basic fundamental quantities are the mass, the length, and the time. And the unit of mass is kilogram. The unit of time is seconds. The unit of length is what? Meters. So now we're going to be looking at the units and dimensions. And before we go to that, we need to know what dimension actually is. What is dimension? The dimension of a quantity simply refers to the symbol allocated to that quantity irrespective of its units. So let's see what we are going to be looking at here. Let's see quantity. Units. And the dimension. The first one is what? Mass. Mass refers to what? The quantity of matter in a body. In this class, we'll be focusing on physics calculation, so this one is just a tip. Some things you need to understand before we go fully into calculations in what physics. So now mass is the quantity of matter in the body. The unit of mass is kilogram. And the dimension, which is the symbol allocated to mass, is m. That's the dimension for mass. Now we have length. The unit of length is meters. The dimension of length is L. The next one is time. The unit of time is seconds, which is S. This one is meters, actually, M-E-T-E-R or T-R-E. It's normally represented with N. And seconds speaks of time, okay? Unit of time is seconds. Then the dimension of time is T. So these are the three basic fundamental quantities in physics. And these are the units, and these are their dimensions. So now let's proceed now. Let's talk about area. Unit of area is meter square, which is meter times what? Meter. And the dimension from here m squared. So dimension for length is L. So dimension for area, which we obtain from m squared, becomes L to power 2. That's the dimension for area. Next, let's look at the dimension for volume. The dimension for volume, the unit of volume is meter cube. The dimension for volume becomes L to power 3. These things are actually not difficult because once we know the dimension of mass, length, and time, which is the MLT, from there you can obtain the dimension for other quantities in what physics. So the next one we are going to look at is density. We look at density. We look at speeds or velocity. Now look at acceleration. Acceleration. Okay, now let's say density. Density refers to density is mass over volume. Mass over volume. The unit of mass is kilogram. The unit of volume is meter watt cube. The unit of mass is kilogram. The unit of volume is what? Meter watt cube. So that means that the unit of density becomes kilogram meter to power minus 3. That's kilogram per meter watt cube. So from here we can obtain the dimension. Kilogram speaks of what? Mass, okay, the unit is kilogram, meter per meter cube, dimension M, meter speaks of length, that's L, then to power minus 3. That becomes the dimension of what? Density. The next thing we need to look at is the dimension of speed or velocity. Speed or velocity. Now speed and velocity have the same units. So speed or velocity. Speed is distance over time. And velocity is displacement. Displacement over time. Displacement over time. So unit of displacement and unit of distance is the same thing, which is meters. And time, seconds. So unit of speed or velocity becomes meter per second. Meter per second. Meter per second. So the dimension of speed or velocity from here, the meter speaks of length, second speaks of time, then to power minus what? 1. That becomes the dimension of speed or velocity. The next one we have here is acceleration. Acceleration. So acceleration refers to change in velocity. Change in velocity with time. And rate of change of velocity move with what time? Okay? Rate of change of velocity move with what time? So now, the unit of velocity, we know that velocity is what? The unit is meter per what second? Meter per second. The unit of time is what second? So unit of acceleration becomes meter per second. And that is meter per second what square. Meter per second square. Meter per second square. So the dimension of acceleration will now be the meter speaks of length, the second speaks of time, then to power minus what? 2. These are easy things for you to what? Memorize. Or better still, just understand the basic dimension for mass, the length, and the time. If you understand that, from there you'll be able to derive the dimensions of other quantities. If you enjoyed this video, ensure you like, you share, you follow us, if you're watching on Facebook or watching on TikTok, and then ensure you subscribe to our YouTube channel for more tips.